Parabuild is steel detailing software that can model all types of structural steel in 3D. It automatically produces the bills of material, shop drawings and CNC files needed to fabricate and erect a structure. In this video, we'll look at drawing stairs and railings with Parabuild. One way to draw a stair is on a line. The line determines the location, start, end, length and slope of the stair. And the stair will remain constrained to this line and will automatically adjust when the line is moved or stretched. After starting the command and selecting the line, the stair type can be selected from the available options. These are all constrained template drawings, and the user can adapt them or create more. Once drawn, you can edit the stair parameters, such as the number of treads and the stair width. And if you move the line, the stair and all its parts will be automatically updated. The stair can also be drawn from the ground to a floor beam. Only the top beam needs to be selected on the side where we want to place the stair. Next, a reference geometry is chosen to determine the horizontal placement for the stair. Then, the stair type can be selected from the available options. Now, we can edit the various parameters of the stair. As the stair offsets change, the true stair spacing will be indicated as a reference. At all times, you can return to the stair parameters dialog by double-clicking on the macro sphere. Let's look at drawing a stair running from beam to beam. First, the top beam is selected, and then the bottom. And in this case, a grid line is selected as a reference for the horizontal offset of the stair. And from the Edit dialog, we can again edit any of the stair parameters. Individual parts and cuts can be removed and replaced without losing the overall intelligence of the stair. Railings can be placed on the edge of individual members or on a single line. After starting the command, the railing type is selected from the available options. Then, the edge of the beam to place the railing on is selected. The railing, with its kick plate, is drawn to the full length of the beam. After drawing the next railing segment, you'll see that Parabuild has automatically connected the two railings with bends. In this case, we don't want the segment to be drawn along the whole beam, but instead it should stop at the stair. This can be done by selecting the outside flange of the stair stringer, indicating we want to stop the rail at that point. And when placing the next segment on the stringer, you'll see the rail continues up the stair with the bends automatically placed. Railings are comprised of multiple macros, and each one can be edited separately, replaced or removed without breaking the overall intelligence of the railing. In this location, where the ends of the railing were terminated with closures, we want to replace them with continuous bends. So first we delete the closure macros, and by choosing railing intersection connection and selecting the two railing endings, the bends are automatically placed. We'll now move the railing to the outside of the platform. First, a switch to plan view is done. Then, after modifying the offset values in the edit dialog, you'll see the modification has been carried through the entire handrail. Next, we connect the handrail posts to the steelwork. With the propagate tool, the connection will be copied to all other rail poster beam instances. Stringers are detected as a different type of situation, so to connect the railing post to the stair, they have to be connected separately. Changing the number of posts will automatically add or remove these post connections. For more information, please visit us at our website at parabuild.com.